Good evening, thanks everyone for coming. I'm here tonight as your host, Christian Southall, who normally does this part of the evening. He's having a well-deserved break somewhere gallivanting around Europe at the moment. First time he's having a holiday in a long time, so well-deserved. I'm glad that he's over there. Really appreciate you coming down tonight. We've got an exciting talk, so very much looking forward to that. Housekeeping, men's and ladies' bathrooms are over there. If you haven't been here before, feel free to grab a drink and pizza if you haven't already, or throughout the talk. We've got a couple of good talks coming up as well, so just to spruik the agenda we've got in the coming months, we've got a talk next month on using machine learning to recommend properties for people who are looking to purchase a new home. We do also have like a small slot there for like a 15-minute talk or 30-minute talk if someone has anything that they'd like to bring to the group. We'd love to hear from you about that. And then in September we'll be celebrating 10 years of Perth AWS User Group, which is a pretty phenomenal achievement. And right at the time we've crossed 1,600 members on Meetup, so obviously we don't have 1,600 here tonight, but still a pretty good show, I would say. So for the 10-year anniversary we're looking to do something a little bit different and have a few stalwarts of the Perth AWS scene share some of their perspective over the last decade and perhaps some crystal balling into what might come in the near future. Who knows, hey? As always, the organisers would love to hear from you if you have any feedback about Perth AWS User Group. We'd also love to hear from you if you have a talk you'd like to give or someone you'd like to hear from, just to kind of keep our content schedule busy. We're trying to get more proactive and get that sort of built out more in advance so we can deliver high quality talks to the audience here. So we'd love to hear from you. Please reach out if there's anything you'd like to share with us. In terms of this evening talk, we're lucky to be joined by Greg Biegel. Greg's a cloud architect with AWS up the top of the road here. Greg's well-travelled, and I want to share with you some of his highlights in his illustrious career. So if you have bought fresh food in Cape Town, used a cheque in Zimbabwe, bought an NBN service in Australia, which I'm presuming a lot of you have, sent a parcel by Australia Post, provided a specimen for cancer trials in Australia, booked a Ministry of Transport test in the UK, or visited a National Gallery in London, you might have encountered some of Greg's code. And he hopes that it worked most of the time. We're very lucky to have him here talking about TwinMaker this evening. I think it's hugely relevant to the market we're in here with a lot of heavy industry, mining, energy and industrial, kind of epicenter of Australia, I would call it, and I think very relevant to the market in which we live. And so very much welcome Greg here for tonight's talk and to share with us. Thank you.
Awesome. Cool, thanks James. Thanks so much for the introduction. I'm really happy to be here this evening, and I just wanted to say a big shout out to the organisers of the user group. I know how much work goes in the background, so thanks a lot. I've really enjoyed all the events that you've put on this year. And thanks to the sponsors of this evening's event. So as James said, my name is Greg. I'm a cloud architect with ProServe here in Perth. And this evening, I'm really looking forward to talking to you about how you can use a lesser known AWS service, perhaps, known as AWS IoT TwinMaker, to build an immersive three-dimensional digital twin. So I'll start this evening's talk off with a little bit of theory. So we'll cover the definition of what a digital twin is and why you might want to build one. Talk a little bit about why building a digital twin might be difficult. I'll then give you an introduction to the AWS IoT TwinMaker service, and then tempt the demo gods and give you a demonstration of a relatively simple digital twin that I've built in TwinMaker, and that is running here this evening. So digital twins are one of the key components of the Industry 4.0 initiative, which refers to how companies are using technologies such as machine learning, IoT, and cloud computing throughout their operations and processes to revolutionize the way that they manufacture, distribute, and improve their products that they send to their customers. It's not a new concept. In fact, my favorite example of a digital twin comes from around 50 years ago during the Apollo 13 space program, when NASA used the equivalent of a digital twin to bring a crippled spacecraft back to Earth. There's a really good blog article that describes that. It's a really good read. I really recommend that if you get the chance, you read it. I've got a link at the end of the demonstration, at the end of the presentation. So yeah, it's really good. At AWS, we adopt the definition of a digital twin as being a living digital representation of a physical system that is dynamically updated to mimic the structure, state, and behavior of the physical system that it represents to drive business outcomes. And to me, this last part of the definition here, the business outcomes, is the most important. So before embarking on a digital twin journey, it's really critical that you try and understand what business outcome you're trying to achieve with your digital twin. So I can't stress that enough. Cloud computing, machine learning, Internet of Things are really transforming the art of the possible in our industry. And the continuing convergence of those technologies and their development is enabling the deployment of digital twins at scale. In particular, the continuing reduction in cost of IoT sensors means that measurements that may have been cost prohibitive 10 to 15 years ago have now become commodity. And the value of a digital twin is using the data produced by those IoT sensors and other data sources to drive actionable business insights. This is achieved by at-scale compute provided by the cloud to run modeling, simulation, forecasting, and to take that data to combine it with 3D content to provide compelling visualizations and bring that data closer to your users. So again, at AWS, we define 4 levels of digital twin in our discussions with customers, and we find that this definition really helps to level set any discussions that we might have about a digital twin. So at L1, or descriptive digital twins, this is really just a static digital representation of a physical system. So that might be something like an engineering diagram or a CAD model. It's not updated at all. It's just pretty static, but you can still derive value from it. At level 2, we talk about informative digital twins. At this level, we start to see data sources being used to update that digital representation. So we see integration of IoT data, perhaps engineering data, maintenance data, etc. We then move to level 3, or predictive digital twins. At this level, we start to see predictions being made based on models within the twin, as well as data from the past and the present. The final level is L4, or a living digital twin. And the distinguishing feature of the L4 digital twin is really the use of that data from sensors and IoT devices to update your models to drive more actionable insights. So building and managing digital twins is costly, complicated, and time-consuming. And there's a number of reasons for that. But really, you need a group of specialized developers with really specialized skills working together to build a custom integrated solution that draws data from many different disparate data sources. So, different data formats, different protocols, different frequencies, etc. And contextualize that data, and then to provide effective visualizations of that data to allow your users to achieve a valuable business outcome, really. So, and even large organizations with large development teams and many skills can find this difficult to do. So AWS IoT TwinMaker. This is a service that gives you the tools that you need to be able to build a digital twin that can help you to optimize your factory operations, improve your equipment performance, or optimize your industrial operations. And it does this by giving you the ability to access data no matter where it lives. So there's no need to import the data into TwinMaker. The data remains in place. It gives you a tool to create a representation of your physical environment in the digital world. And then finally, it allows you to join that data to existing 3D content to provide compelling, intuitive, immersive reality type visualizations that your users can really use to, drive insights. So what is TwinMaker? Starting at the top here, TwinMaker has the concept of a workspace. A workspace is really just a logical container of all of the other assets within your digital twin. Practically speaking, a workspace is an S3 bucket and an IAM execution role. The S3 bucket holds all of the assets, and the execution role defines the security boundary of the digital twin. And within our workspace, we have a bunch of assets. So we've got both data-focused assets on the left here in orange and visualization-focused assets in purple on the right. Starting with the data-focused assets, the first asset is a component. And a component is just an instantiation of what's called a component type in TwinMaker. And a component type literally is just a JSON document that defines how data is accessed from an existing data store and made available within your digital twin. There's a couple of component types that ship out of the box with TwinMaker to allow you to access data in some native AWS services, such as Sitewise and Kinesis video streams. TwinMaker also comes with a framework that allows you to build custom component types to access data from pretty much any other AWS service, or indeed external services such as Snowflake or OSI Pi. Entities are just assets that are used to build up the representation of your physical world. So if we think about an industrial plant, quite often an industrial plant is made up of a number of real-world entities and relationships between them in a parent-child relationship type structure. So that's what entities do. Entities draw their data from components. So in an architectural pattern called entity component system architecture, which is quite common in computer gaming, entities don't hold much data themselves, but they draw it from components, and there's a many-to-many relationship between components and entities. So moving across from the data-focused to the visualization-focused components on the right here, the first one is the scene, and a scene is really just a logical container of visualization assets, much the same way that the workspace is a container. A scene can display resources, and a resource is a three-dimensional object that is either in the GLTF or GLB file format. That's the graphics language transfer format, which is seeing a lot of adoption in industry. So, sorry, I'm getting the buttons wrong here. Scenes are composed of nodes, and nodes can be one of multiple types and can also exist in a parent-child hierarchy. So the types of nodes that we have are again divided into data-focused in orange and visualization-focused in purple. First of all, we have the empty node, which is just a structural element to allow you to build up a hierarchy within your scene. We have a shader node. This node allows you to change the color of a three-dimensional object based on data binding. A light should be self-explanatory. You can add an ambient or a directional light to your three-dimensional scene. And a 3D model is a 3D object that you can place within your scene. The sole data-focused component within a scene is a tag. And this is a really important component because this is what ties your data-producing component on the left here into your three-dimensional scene so that you can mix real-world data with a three-dimensional visualization to provide that rich interactive experience. So that's, tags get data from components. And that's pretty much what a digital twin in TwinMaker looks like, and we'll jump into a demonstration a little bit later and see what it looks like in the console. So how does it all work? We've got all of these bits and pieces that make up our digital twin. So they all run within AWS, within TwinMaker, so running within the cloud, your digital twin executes. It draws data from data sources either within AWS or outside of the cloud. It's pretty flexible. And your digital twins consists of your integrated asset model and your 3D visualization here. And it's made available to your users, because at the end of the day, you're building a digital twin for people to use via an end user web application. And there's a couple of ways in which you can do that, which I'll cover later. And then we have our personas who typically use that digital twin. So, you know, operations staff are interested in the operating health or performance of your asset, and planners are obviously looking to the future. So within TwinMaker, we have 4 key pillars of functionality. Starting on the left here, we have our data connectors, which allow you to access data from a diverse set of sources, as I've said. And you can either use the built-in data connectors or you can build your own. The model builder is a component that allows you to create this, virtual representation of your physical environment by building up your entities and their relationships into a hierarchy, and to connect those 2 data sources to form what we call a digital twin graph. Scene Composer is the 3rd pillar. This allows you to combine your existing 3D visual models together into a scene and to tie data into that scene. So to join the visualization with the real world data. And then finally, App Toolkit is the pillar that really allows you to serve that digital twin to your users via the web. So diving a little bit deeper into each of those 4 pillars, our data connectors, I think, as I've said, you get some out of the box to services such as IoT Sitewise, Amazon S3, Amazon KVS. But what's really key is this flexible framework that allows you to build your own connectors. And I'll give you a demonstration of an example of how you do that to draw some data out of DynamoDB. Because that's not one of the built-in connectors with TwinMaker. So I'll show you how easy it is to build one of those connectors. The model builder is a key component, and this allows you to build up your digital representation. So if you think in the real world, most things are entities that are related to each other in some way, and the model builder allows you to use those, to build those relationships up in the digital world. To represent the physical world. So the example on the right here, we have at the top level our facility entity. Our facility might be a manufacturing plant or a factory, and that has 2 pieces of equipment within it that are children of that facility, equipment 1 and equipment 2. Data about those pieces of equipment is stored in 3 different systems, Sitewise, S3, and an external component, let's say it's Snowflake. So we have components that draw data from each of those systems into TwinMaker and are tied to our virtual representation of our physical system through Model Builder. Scene Composer is the 3rd key pillar, and the key thing to note about Scene Composer is that it's not actually a 3-dimensional editing tool. You can't create 3-dimensional content in it. But what it does allow you to do is bring your existing 3D content and compose it together into a scene. So you can bring your existing CAD models, BIM models, photogrammetry scans, or point cloud scans, convert them into GLTF, and then compose a scene from those different assets. And the example on the right here is taken from our sample cookie factory demo that comes with TwinMaker, and there's a link at the end of the presentation. But this represents a cookie factory with a number of lines and mixers and pumps and tanks, all of which are individual 3D files that have been composed together into a scene. And then Scene Composer allows you to tie that data together with that 3D content to create those compelling visualizations. And sorry about that. The last final pillar is the App Toolkit, which is how your digital twin is served to your end users. And there's 2 mechanisms by which that can be achieved in TwinMaker. One is through a low-code app, so a plugin for Amazon Managed Grafana or open source Grafana. And the other is via what we call our App Toolkit, which is a set of React components that you can integrate into your own custom React web application if that's how you want to go. There's a bunch of really great content on GitHub to show you how to do this. There's a lot of great examples, and I've got links at the end for you to take a look. So tying it all together, how does what does it look like when we want to build our digital twin with TwinMaker? And this will influence the demonstration that I'll show you this evening. So on the left here, we've got our hardware devices. So we've got a bunch of IoT sensors, cameras. It could be data from existing enterprise systems, such as maintenance or engineering systems. That's ingested, typically via an edge service, such as Greengrass or Sitewise Edge, or IoT Core, which is the way that I'll ingest the data this evening. Once it's ingested, it's stored either within AWS or outside of AWS. And then we go into our digital twin within TwinMaker here. And first of all, we have a bunch of connectors to draw the data from the data store into the digital twin. And then we have our metadata store, which contains our entity hierarchy built with Model Builder and tied to our components, which connect to the data stores via our connectors. And we've got a bunch of APIs here that will provide the digital twin data to our consuming applications, so our Grafana dashboard or our custom web application, or indeed custom analytics applications. So, the whole intent of digital twins is to move higher up in the hierarchy to predictive digital twins, where you're actually running models and custom analytics over the data, and that's all provided for by the APIs coming out of TwinMaker. So I'd like for you to maybe just take a moment and imagine that you're the owner of this wonderful space that we're in tonight, and you have a bunch of tenants who are renting space from you in the building. So your goal as the owner of the space is to delight your tenants and to provide the most comfortable building experience that you can. And you've got a couple of levers that you can pull there. One of them is ambient temperature. Now, unfortunately, the HVAC system that you have in the building is pretty old, and it doesn't interface with your modern IT applications. So you can't really get that data out of that system to understand how your building's performing. So you've decided to take some commodity off-the-shelf hardware and build yourself a digital twin so you can get a better understanding of the environment that you're providing your tenants, and you can take action to improve it if the temperature gets too warm or it gets too humid. So bearing that in mind, the architecture of the little demonstration tonight is that we've got some off-the-shelf hardware here on the left. So I've got an external air sensor that I've blue tacked to the wall outside. Hopefully it's still there. I've got an inside air sensor sitting here on the table, and these are both LoRaWAN devices. So this you can get on AliExpress for about $5 to $10, very cheap. It runs on 2 AAA batteries, and it runs over 915 megahertz. And the batteries at the sort of 20-minute frequency that it defaults to should last for, I think they say, a year or so. And it's got a pretty good transmission range. So I've tested it to 500 meters. So those 2 LoRaWAN sensors are connecting to this LoRaWAN gateway that's sitting here. Again, just a cheap off-the-shelf LoRaWAN gateway. That LoRaWAN gateway is then connecting to the Wi-Fi router on my phone there and sending the data into IoT Core for LoRaWAN here. And there's a little Lambda that's then storing the data in DynamoDB. I've also got a Raspberry Pi camera, which I need to start. Let me just do that. Okay. So I've got a little Pi camera running on a Raspberry Pi Zero there. Again, that's about $20, I think, for that board, so very cheap. And that's sending data through the Wi-Fi router on the phone into KVS. So none of that's got anything to do with TwinMaker just yet. But then we move into the TwinMaker side of it, and I have a custom connector that I've written with the TwinMaker framework, which will allow me to get the time series data out of DynamoDB that's come from my air sensors here. And I also use the out-of-the-box KVS video connector to draw the stream from the little Raspberry Pi camera there. And then I've got a Grafana dashboard, which will display the time series data in the context of a simple three-dimensional model. And as my building operator, I can log into that dashboard wherever I am in the world and gain a better understanding of the environment of my asset, which is RIF, where we find ourselves tonight. So I will now jump into the console and show you what it looks like. All right, so I'm in the AWS console here. I'm just starting off with the way in which the sensors are connecting into AWS, and that's using AWS IoT Core for LoRaWAN. Fantastic service. It's brilliant, and I really enjoy it. I won't have time to dive into it too deeply this evening, but I'd love to talk about it in more depth with anyone who's interested. But I've registered my 2 LoRaWAN sensors in there. So I've got my outdoor temperature and humidity sensor, my indoor temperature humidity sensor, and hopefully they have both sent some data recently. I can just check on the uplink received here. And I'm going through my hotspots, so it's not the fastest. Okay, great. They both sent some data in the last 5 minutes. Cool. So jumping into the TwinMaker console, like I said, the highest level component that you need to deal with in TwinMaker is called a workspace. I've prepared a workspace earlier, so it's called 34 Digital Twin Workspace. And in here, as you can see, a workspace doesn't have a huge amount of data. It's got an S3 bucket and an execution role. If you are a customer of IoT Sitewise, you can import your Sitewise asset hierarchy into TwinMaker through this function here. I'm not going to show that this evening, but just for awareness, if you are a Sitewise customer, you can do that. So going from workspace, I then go into the component types screen. And you can see that there's a bunch of out-of-the-box component types. Recall that component types define how data is accessed from external data stores and brought into your digital twin. So I've got all my out-of-the-box components down the bottom here. And at the top here, I have 2 custom components that I've created for the demonstration. The one that I'll talk about is this air quality component type. So I'll just jump in to show you how I define a component type. I've got a CloudFormation script, and I can share this after the meetup. And there's just one thing that I wanted to show you in the CloudFormation script, which is my air sensor component, and that's of type IoT TwinMaker component type. And all I need to define is 2 Lambda functions. So I need to define a schema initializer Lambda function, which defines the structure of the data, and a data reader Lambda function, which actually gets the data from the data store. For the DynamoDB connector type, they're both very simple. The schema initializer is just showing the structure of the data. So we have a temperature reading, a humidity reading, and a CO2 reading, although I wasn't able to get the CO2 sensor, so that's irrelevant. But temperature and humidity, they're both double data types, and they're both time series data. Going across to my data reader function, again, very simple. All that it does is it queries my DynamoDB table, and it formats the data in the structure that TwinMaker expects. And that's all documented within the TwinMaker documentation. But really all that this component type, all that this Lambda does is runs a DynamoDB query, and then it sort of reformats and mangles the data a bit into the format that TwinMaker expects. So I've defined those 2 Lambda functions, and I've defined the component type in CloudFormation. And so now that component is available for me in TwinMaker. So moving from component types, I now go to the entity screen. And the entity screen is my model builder component. So this is where I build up my hierarchy and my representation of the physical world. So I'm starting at the top with an entity called RIF, which represents this room in which we are tonight. I haven't associated any data streams to RIF itself. There's nothing at that level that's providing data. But within Riff, I have two container entities, one for surveillance cameras and one for air sensors. Again, cameras and sensors are just container entities. But if I go to the surveillance camera entity, this will be the first entity that I've associated a data stream to. So I've associated two components to my surveillance camera entity, and I'm calling my Pi camera a surveillance camera. It might be a bit of a grand term, but anyway, it's a camera. So the camera component is using the out-of-the-box KVS connector. So we can see Amazon KVS video, and that has a bunch of properties that are defined on it. So pretty much the most important one is the Kinesis video stream name. I've also added a out-of-the-box component called manual, which just associates my entity with a document, because having that contextualized information of being able to look at the documentation for your hardware in the 3D scene is quite useful. Moving down to my sensors, I've got my two air sensor entities. If I look at my indoor air sensor entity, I've associated three components to it. So it draws data from the air quality component, which is drawing data from DynamoDB via my custom connector. I've associated the alarm custom component, which is just a component that indicates when a reading is in alarm. And I've also associated the manual with it too. So that's pretty much the simple entity hierarchy for the digital twin here this evening. You can imagine in a complex industrial plant, it would be a lot more complicated, and you might have a lot more data sources and a lot more complex relationships, but I'm keeping it pretty simple. So having done that, I can then jump into my three-dimensional scene. Now, I don't have a CAD model for Riff, unfortunately, so I've had to improvise, and I've downloaded something off the internet, which is always the best way to do it. So I've got what's, I think it's called a classroom three-dimensional model, but I thought it represented the room that we're in this evening sort of quite faithfully. So I've composed a scene with a couple of three-dimensional components. The first is the classroom. I've then added in a little air sensor model over here on the wall, and I've added a camera sensor. And those are all individual 3D models that I've just downloaded from a free 3D asset site on the internet. I have also added a, oh, sorry, I'm just driving. This can be a bit difficult with just one hand. I've also added a air sensor component on the exterior of the room. Like I said, I've blue tacked a little sensor on the outside of Riff, and that's there. So looking at what that looks like in my scene composer, on the left here is my office, and I've made some children nodes representing the air sensors and the camera. And I have also added a tag to each of those two air sensors and the video. So if I expand out the air sensors there, I can see that I've added a tag, and I'll just go back inside here and show you what the tag looks like. The tag is this blue circle here. So I've added the tag into the scene, and I just click and I drag and I place it, and I'll show you how that looks as we move on. And then on the right here, what I do is I associate my tag with some data from my component. So for this particular air sensor, I've chosen to display the temperature. So I've put the entity ID, the component name, and the property name defined here on the right. I could have chosen any of the three properties that are available, but I've chosen temperature. I can also define a rule. And what this rule does is this rule then will change the look of that tag based on the data that is bound to that tag. So given that I've got temperature associated to it, my temperature rule here would change the the look of that tag based on a data binding. And why that's useful is that when you have a large three-dimensional scene with lots of data related to it, those visual indicators can really make it easy to see where you might have a problem. So that, I think, is pretty much everything in the scene. So we're still, in this view in the console, we're still very much in the design view of our digital twin. We're still setting up our entities, we're setting up our data sources and our components, and we're tying it all together. Once we've finished that and we're happy with it, we can then move to serve that digital twin to our users. And like I said, there's two ways in which you can do that. So the first way to show you is just this, click out of there, is a Grafana dashboard. So TwinMaker provides a bunch of out-of-the-box components for Grafana, either managed Grafana or open source Grafana. I'm using open source Grafana here. And you can build up rich interactive dashboards based on your digital twin. So a couple of the interesting component types. I might just go back for the last hour and yep, okay, it did bring some data back. So normally what I would do is I would start off in my three-dimensional scene here, and I can navigate around it, and I can go and say, once again, if I'm my building manager persona, I want to understand what the environment within the room is tonight. I can go and I see that there's a tag here that represents a sensor. I can click on it. And it will go and it will retrieve the data that is related to that tag. And it'll display. So there's two time series pieces of data up here for humidity and temperature. There's a video stream associated to it. And because I've gone back in time a little bit, you can see that we're all sitting around having pizza and beer earlier in the video stream coming from the Raspberry Pi. If I want to maintain this sensor, I can click on this link, which will take me to the user manual for that sensor. And all that information is tied together. There's also a view of alarms that are operating on that sensor. It's currently just dummy data. There's nothing real about those alarms, but the intent is to give you a view of the different visualizations that you can build together. And then you can obviously move back in time and see what the state was of your sensors, your time series data, etc. Over time. If I were to navigate outside here and say I'm interested now in the external temperature, I would click on the external tag and see that the temperature outside is currently at 20 degrees. So that's really that actionable insight that the digital twin is trying to give you. The other way in which you can serve this digital twin is via a custom React application. So I've got a simple one running here this evening that just really tries to show you some of the app components that you can take out of the box to integrate into your React application. And this is the scene viewer, so you can get a nice three-dimensional scene within your React application without having to do too much heavy lifting. I'm going to jump back into the presentation now. Just go from play from current slide. So that 3D visualization and the tying of data together is fantastic. But what we find for a lot of our customers is that they don't have necessarily those 3D assets available of their plant or equipment. So, and even if they do, they don't always reflect reality, because often a CAD design is not what was built, and they may be out of date. So another way in which you can put three-dimensional scenes into TwinMaker is by creating them yourself from photography. So I won't go too much into detail in this pipeline, but this is a pipeline that we've built that allows you to take regular photographs off your mobile phone or a drone, use a process known as photogrammetry to compose a three-dimensional model out of those ordinary two-dimensional photographs, and then to put them into a scene in TwinMaker. And just an example of how you might be able to do that just with your mobile phone is here. So this is just a pump in my local park. And I have a free application on my phone. Not sure how I can play this. Oh yeah, there we go. I'm using an application called Pix4D Catch, which is basically just a simple application that allows you to take photographs, multiple photographs that are ideal for photogrammetry, which is reconstructing a three-dimensional scene from two-dimensional photographs. So running this application, you just move your phone around the object that you would like to survey, and then that creates, I think at the end of the day, I create about 150 photographs in a couple of minutes. And then you can feed those photographs into that pipeline that I showed earlier, and you can create a pretty faithful representation in this three-dimensional scene. So just to show you what that looks like in TwinMaker. This is the 3D scene generated from photogrammetry from the mobile phone. You can see it, it's not perfect, but it's pretty close to reality. Once you've done that, you can start to add other 3D entities into the scene. So I might want to add something that indicates which way the water is flowing in this pump, because that would be useful information. So I can add what's known as a motion indicator in TwinMaker. And I've got that there. And what I can do then is I can tie that motion indicator, I can bind it to some data. So let's say I've got a flow meter on my pump, which is reporting the data of the flow rate of liquid through the pump. I can then tie it. I don't have that, so I'll just I'll just select a speed. But you can see this dynamism of being able to tie motion indicators to data to give you that insight that previously you might have had to swivel chair to another system to understand the flow rate within your pump. What this allows you to do is really bring all of that information together in an intuitive and easily used visualization. So it's not just, that's a pretty small asset, and although I think it looks pretty decent, quite often our customers have much larger pieces of equipment or assets that they work with. So you can do the same with drone photography. So this is one that I created of the old South Fremantle power station. Again, this is just using a very quick drone flight. I think it took about 20 minutes and it took about 150 photographs. I put those into the pipeline, and using photogrammetry, it created the three-dimensional model and then converted it into a TwinMaker scene. So you can imagine as somebody who's operating a large complex asset, which might be a hazardous environment, you might not want to go in there. The ability to quickly create a visual representation of that asset in 3 dimensions and then to tie data to it can be pretty valuable. One of the other things that you can do in TwinMaker, and I'll just try and drive to the right place, is I might want to add annotations within this model. So we might have multiple people working on this model who want to communicate or mark up the model in some way to add additional context or information. In TwinMaker, you can add what's called an annotation. So I can add an annotation here, and I can set that annotation to have some markdown. Let me just think what I want it to do. Photo. So I have a photograph that I prepared earlier. So I've added an annotation that says, at this point in my model, I have a photograph that adds extra information about this asset, and a user can come along and click on it. And I did not start the server, so it's not going to work. Okay. I think it was port 8000, perhaps. Let's try that. That's better. So that then links me to a photograph of the where I can actually see what the real state of that asset is. So photogrammetry is great, but it doesn't give you a true reflection of reality. So sometimes you want to link to photographs or other documents or sensor data, etc. So one of the, I'm just checking time. I've got a few more minutes, have I? Cool. One of the other things that you can do, you can also take free photogrammetry data sets that are available online or other 3D models. So there's a really fantastic photogrammetry scan of the entire city of Melbourne that's available for free online. And I've taken just one block from the city and put it into a TwinMaker scene here. And as you can see, you can get a very good representation of reality right here in the console, which you can then serve up through your digital twin to any other users. So the last scene that I think I wanted to show was, I had a stab at just creating a scene with my mobile phone in here earlier this evening. I'm not sure if you can recognize it. It hasn't come out that well because I don't have the best phone camera. But this is just a scan of the kitchen around the corner there. And really the key here is that with a pretty low barrier to entry, with just the mobile phone in your hand, you can produce some pretty compelling visualizations, which you can then tie data into and serve up to users. Obviously, the next step, and I won't have time to talk about it this evening, is to tie in prediction into your digital twin. So to take machine learning models, and there's a really good demonstration on our GitHub page of using an off-the-shelf anomaly detection model, put it against some time series data, and start to predict when items might fail or you might have problems. And that's kind of moving up that digital twin value chain, if you like. And I think that's pretty much everything that I had to talk about this evening. I know it's been a lot and I've raced through it, but has anybody got any questions? David?
Links where you can get those sensors from.
Sure, I will do. I've had them running in my house for a few weeks, and it's great. I've discovered that the house is very humid inside. I'm not quite sure why. Sorry.
Yeah, I really like the whole 3D modelling. But does it work equally well with sort of traditional 2D mapping and geospatial? Especially like there's a use case which I potentially have devices which might go around a nation or even globally, something like that. So I don't really need the full 3D, but I need to be able to
good.
how they're going. I guess taking the right level of detail.
Fantastic question, and I think the answer is probably not currently in terms of that geospatial. I know that geospatial capability of being able to have that global coordinate reference system is hugely valuable. The scene composer currently doesn't have an approach to that that I know of, but I can chat to the team and see what the plans are for that. But yeah, not that I currently am aware of.
Yeah, because this seems to be more of a bottom up, if I think of it that way, rather than a sort of top down. And it'd be nice if you could drill either way.
Yeah, absolutely, and I think it's really important. I think there is one other thing that just related to that, I guess, is you'll notice that I preloaded a lot of the scenes, and there's a reason for that. And the reason is that these scenes are pretty large files, and they can take quite a long time to load. TwinMaker now has support for cesium. So with cesium, I can show you an example here where I've got my power station that I've put in as I've transformed to cesium. And the reason that that's kind of relevant to what you're saying is in cesium you can then geolocate your model. So I've taken the power station and I've put it in the right place in the world in cesium.js, or cesium ion, sorry. And so you can geolocate your scene, but yeah, you don't get any spatial capability with it. But what does happen with cesium is that your scene loads a lot quicker because it loads levels of detail. So the cesium scene, you can see they're loaded very quickly. The the regular GLB scene would take a couple of minutes to load because it's a couple of 100 megabytes. Hey.
Does the TwinMaker allow user to input dimensional reference? So saying we want to measure, dimension.
Not currently, and that's a feature that I think is hugely important when you want to do stockpile measurements or even just distance measurements. So no, it doesn't currently support that measurement functionality, but yeah, that's hugely important and valuable, and I'm sure that I imagine it would come because it is so important.
Is there a simple way for importing devices into TwinMaker, for example? If you're adding a device that will output to an existing DynamoDB that you're already sourcing 20 devices from, will it appear there and say, hey, we've got a new device, where is it? Or what type is it? You can easily go boom, boom, without actually having to add all the metadata in addition.
Yeah, not out of the box, but everything's API driven. So you could imagine that you could build a capability, that kind of, I guess, that sort of auto discovery capability that you I think I understand you're saying, with the APIs. Not out of the box currently, but yeah, certainly extensible to do that. Hey.
The performance, I guess, of all the underlying data stores you showed is amazing.
Yeah.
Can IoT TwinMaker keep up with that and display data which is updating in minutes or seconds?
Yeah, good point. I mean, it's whatever TwinMaker can show is constrained by your source data store, right? So I'm showing a pretty small DynamoDB table. Obviously, if the latency of your source data query is greater, that's going to be reflected in your digital twin. So you're very much constrained by your source data, which is, the benefit is you don't have to import your data into TwinMaker, but yeah, you could be exposed to the performance of your source data store.
Yeah, it's slightly different. Right?
Yeah. If I have data which is updating every 10 seconds, can TwinMaker keep up?
Yeah. So all that TwinMaker, the digital twin in Grafana or your Reactor, all that's doing is exercising a TwinMaker API. And all that TwinMaker API is doing is then exercising your connector to run the query. So in theory, yes, I can set Grafana to refresh every second, and it'll just issue a call to the TwinMaker API, which will then issue a call to the underlying data connection. So it should be able to, yeah. Cool. Hey.
So you mentioned it takes a big GLB file a long time to load.
Yeah.
If you have the points in space and they're associated with other GLB files, does it load them in on demand, or does it bring them all in at the same time? So as you move through the scene, if it's off-site, it's not going to load, but it loads as you approach it.
Yeah, with the GLB files, it'll load them all in the scene at one time. With the Cesium.js, yeah, as you move around the scene, it'll load the levels of detail as you request them, and as you go closer to the level of detail, it'll load that on demand. So yeah, the GLB is very much all at once. But yeah, the Cesium stuff is super exciting. It's definitely, I think I see that as being the way of the future. Everyone's adopting Cesium, and it's really great to see the support in TwinMaker for it. Hey.
Our source dynamically provide the scene data, so the 3D contents are dynamically changing?
Good question. And I'm afraid I don't know the answer. I want to say I don't believe so, but I'll have to take that on notice and maybe get back to you. I don't believe that it is possible at the moment, but yeah, I can check and get back to you if you like.
For instance, tracking mobile assets in scene or something like that?
Yeah, you can imagine vehicle tracking or person tracking would be a use case that springs to mind. So yeah, good question. Sorry, I don't know the answer.
Even service teams within the plant, perhaps. Yeah.
Yeah.
When it's pulling data,
Yeah.
is it aware of what's visible to the user in terms of the coordinates and the orientation of the view?
No, it's not. It's basically related to the tag. So you can set up the relationships within. So obviously you associate your components to your tags in your 3D scene composer, and then you can also create relationships in Grafana through the use of variables. But it doesn't have that level of sort of almost like a frustum. I'm looking in this area, so get this data. It's related to, I know this tag is selected, so get that data for it. And I hope I've answered your question correctly, maybe not.
Yeah, it's a challenging problem.
It is.
Being aware of your spatial coordinates and what you can see at that point in time.
Yeah, and I think showing a simple scene like I showed this evening, you know, you don't see any problem. But if you were to put an oil refinery into TwinMaker, and you really, heaps of equipment, heaps of data, as you navigate around that environment, you'd want to have that context of, what data is important at that point in the scene.
What was the name of the software you were using for the photogrammetry on the phone?
So that was Pix4D Catch, I think it is. So Pix4D's got a whole suite of photogrammetry stuff. The capture, it's either Catch or Capture on the phone is free. And then they have a bunch of cloud services for the photogrammetry, but I'm using OpenDroneMap in the pipeline. So OpenDroneMap can process any photographs, not only drone photographs. Fantastic piece of software. Yeah, I love it. It's really, really fantastic open source software. Hi.
In terms of cost, to apply these products in a company or in different industries, what is the number,
So
the amount of money that is to insert this product?
Yeah, great question. And because I'm a consultant, I'll say it depends. So it does depend on a lot of factors. So obviously, you would, if you store your data within a native service, you'd have a cost associated with that, which would depend on the region and the service that you use. And then obviously, in the TwinMaker product itself, there's also cost associated with the different features. And it really depends on the number of entities that you have, what region you're running it in, how much data you're storing, etc. So sorry, I don't have a number, but if you've got a use case in mind, I could definitely put together a back of the envelope calculation. But yeah, it really depends on quite a few factors.
Last question, if you can
Hi.
Were you doing the cesium conversions, or did you just go and pull that from somewhere else if you've got it somewhere else?
So I took the cesium conversion, I have the GLB file, and then I use Cesium Ion, the online service. I upload the GLB file, and then that has an export function that you can put in an S3 bucket and your credentials, and it will convert to cesium tiles and send it back to S3, which is how I did the conversion.
So if you have multiple GLB objects in the scene, you have to put the whole scene in there and create it. So you have to put it in a pipeline and say this is everything that's in it.
Yeah.
Create it and then go into the...
Exactly. And I kind of went down that path of trying to combine GLB files together before going to cesium to convert it. But I went down a bit of a rabbit hole. So I haven't done that, but it's a problem that I was thinking about how, it's great to do one, but I've got a scene with a couple of air sensors, a camera, and the office. How do I combine those together and get a cesium scene out of it?
Basically some sort of workflow that says I've built the scene, okay, go off, get the objects, build the cesium file, put it there, now use that.
Yeah.
But then if anything changes at the back end, then you've got to trigger the pipeline again to...
Exactly. And you've got to do it from the scene, because in the scene you've got your placement, right? You've got all your relative locations. You can't just combine all of your GLB files together independently and then convert it, because you don't have your positioning, which is what Scene Compose is all about. So, yeah.
Also, we might draw a close there. Thanks very much, Gregor. It was fantastic. Really appreciate you sharing. Thank you. I know I did. I'm keen to go home and model my own home, and we really appreciate looking after the air temperature here this evening.
Yeah.
For that as well. Everyone's welcome to stick around the network, finish off the drinks, and we look forward to seeing you next month. It's an early session next month, so it'll be 15th of August. And then lastly, it's AWS Cloud Day next week, Wednesday the 26th of July. So if you haven't already registered, I'm not sure if it's still open or not, because I know they were pushing close to capacity on registration numbers, but worth a crack. And if you do happen to be there, look forward to seeing you there. I know there'll be quite a few of us who are here this evening there next week. So say good day. Awesome. Have a great evening.
Thanks all. And there's some of the links I promised. Sorry about all the QR codes on one page, but I'm sure that thanks, James.